Hello, my name is Juan Cabrera-Garcia, and I am the State Extension Specialist for Vegetable Production at the University of Missouri. So today we're going to talk about air quality management in a greenhouse, mostly focused on relative humidity because we see some issues with some vegetable crops when we grow inside a structure and we have high relative humidity. So before we begin talking, let me give you a little bit of background. So when we're trying to put crops inside a structure, being it a high tunnel, a greenhouse with environmental control systems, or indoor plant factory, our objective is to control the environment. We make sure that we keep that environment so that the plants are always in their comfort zone and they're always thriving and developing at their optimum. Ever since we started farming, we started changing the environment by which the plants started growing. Like, for example, out in the wild, the plant was exposed to predators and everything, competition with other plants. But then with agriculture, we try to control the environment in which these plants grow to optimize production. Obviously, farming is our first attempt at controlling some of that environment where the plants are growing. But this is not what we consider controlled environment agriculture. This is just traditional farming. Then we have a high tunnel. That's the next step of technology integration, in which we're controlling temperature and we're also controlling precipitation. A high tunnel, you still grow crops in the soil, and sometimes you do have some environmental control systems, but most of the times a high tunnel is not going to have active environmental controls such as fans, lights, and so on. Some high tunnels do. And the next step of integration is hydroponic crop production inside a greenhouse with environmental control systems. You can see that in the pictures. You have fans, you have water that comes from a nutrient solution tank, and you control the plant nutrition and irrigation frequency with those stuff. And the last step of integration is vertical farming. The point that I want to make with this slide is that we are always striving to control the environment in order to optimize plant production. So the purpose of this presentation is to look at inside a structure, what are the things that we need to look for in terms of the air quality for the plants. So obviously, we want to make sure that the plants have adequate amounts of light, and that's a topic for another time. And if you go back to one of the previous IPM newsletters, I talked about understanding the terminology behind lights and how to use those definitions to shop for lights and make it easy for you to navigate all the mumbo jumbo of terms that are thrown around when you talk about lights for plants. Temperature for cool season crops, you want to have between 65 and 75 degrees Fahrenheit. For warm season crops, you want to have between 65 to 85 degrees Fahrenheit. CO2, for most cases, ambient CO2 levels are okay. I think currently we're sitting at 385 parts per million to 400 parts per million CO2 outside in the air environment. And we're going to talk about why we had to look for CO2 when we're looking at growing plants in a closed environment or inside a structure. Relative humidity, not just the percentage, but how this affects water uptake and water uptake physiology in plants. And the general rule of thumbs when you're growing inside a structure like a greenhouse or a high tunnel, not necessarily a full indoor vertical plant, but a greenhouse and a high tunnel. In the summer, you want to have 1 air exchange per minute. So the whole volume of the structure, the whole air volume that's in the structure, you need to be able to evacuate that air in 1 minute. So that's how you calculate the sizing of your fans, your exhaust fans. But in the winter, you want to have 1 air exchange per hour in the winter. You'll think like, oh, hold on, wait a second, but we need to conserve energy inside a greenhouse because we're heating it and we don't want to lose heat. Why would we need to exhaust air and bring cold air, and then we need to heat that cold air to keep the plants happy? We're going to talk about why you want to have 1 air exchange, why you want to exchange that air during the winter months. And adequate air speeds inside the greenhouse, you want to between 80 to 200 feet per minute in a greenhouse. So let's talk about water absorption, but it's good to understand how plants work. So if you think about you're grabbing water from underground and then bringing it up against gravity, right? So when we have a well that we use to grab groundwater for our own human consumption, we have a pump that's generating the force that will bring in the water to a place where we need it from the groundwater. It can either be a vacuum or a push force, right? But when we look at plants, you have the plant sitting out there. The plants do not have muscles like we do. They cannot exert some energy. So part of water movement through the plants is passive using capillarity, what we call capillarity. But basically that what that means is that the plant has many miniature, like microscopic straws inside the stem tissues. That's what we call the vascular system of the plant. And just because they're very close together and very small, water can get to the plant, to the upper part of the plant passively. And I don't know if you've seen early in the morning, you sometimes see some droplets on the tips of the leaves of the plants. That's due to capillarity. That's just passive water that goes to the plants, and the excess exits through some cavities in the leaves, in the leaves on the plants. But what happens when you need a lot of water, or when you have plants that are very tall, right? And you need to move water. You need an active way. You need some force to move the water. So what happens is that the sunlight heats up the leaf, and the leaf has microscopic gates that we call stomata or stomas. And think about the inside of the leaf at a microscopic level. It's like multiple caves. There's airspace in between. It's like a sponge. So what happens is that the sun heats up the leaves, and that makes some water to evaporate. That makes the water some water to evaporate from the cells inside those leaves. So you have water vapor building up inside these spongy leaf tissue. And what happens is that sometimes the water pressure is too much, and the plants need to relieve that pressure. So they open the stomas. They open the stomatas, the stomates that I said earlier, those microscopic gates that the plants have on the leaf. So what happens is that the sun keeps heating that up. It creates vapor pressure inside the leaf, and the plants open the stomates, and then one water molecule exits the plant as a gas, right? As a vapor. But water molecules have a property that's called cohesion. And what that means is that they have like some sort of attraction between each water molecule. So it's like a chain. So if you pull one water molecule, you're pulling a chain of water molecules, right? If you put a drop of water on a table, and you come with a toothpick and you try to pick the water, you're gonna see that you're just not just pulling one water molecule, you're moving the whole water with the pick. And that's thanks to the cohesion, right? The cohesive property of the water. So what that means is that there's a continuum of water molecules from the leaf of the plant to the stem, to the roots, to the water molecules that are around the root zone. Air comes and it pushes these water molecules. Physical act of pushing the water molecules means that it's pulling more water molecules. It's pulling this chain of water molecules, this continual chain of water molecules from the leaves to the stem, through the roots, from the water molecules that are around the root zone of the plant. So the air keeps pushing those water molecules, and it keeps pulling water molecules from the soil. So that's the force. That's the energy that moves water through the plants. That's the active way of plants moving water. And the reason why I mentioned this is that microclimates inside the greenhouse, or the structure, the high tunnel greenhouse, is going to affect this dynamic. It's going to affect water uptake. So let's talk about microclimates. If you have this closed structure, let's say, for example, and you have the sunlight heating up this structure, you're going to notice that you're going to end up with hot air accumulating at the top of the greenhouse, and you're going to have some stratification of that air. And then you're going to have cool air at the bottom of this structure, right? So it's stratified, it's not even. And sometimes you want to have a mix, like a good mix of this hot and cool air. Like you want to have even air. And if you see in this picture here to the left, you see there's a fan in this picture. This fan here, this is what we call a horizontal air flow fan. And what this does is that it pushes air at an angle. So it's trying to push the hot air from here down here. But at the same time, there's another fan on this side. So the air is going to try to rise here, and this fan is just going to push, and it's going to homogenize the air. And you're not going to have this stratification, right? The other thing that I want you to notice is that we have structures in this high tunnel to manage air quality. You have the side vents here, they're open. You have an exhaust fan, and I think you have a heater here. This is like a space heater. I may be wrong. But also we have these roll covers here, and we're going to talk about that later. Not a physical structure, but notice that the plants are physically spaced. There's good spacing in between the plants, and they're not all crowded. There's no weeds. You cannot see weeds on the sides, and you cannot see weeds growing outside the greenhouse, right? So weeds are going to prevent proper air movement. So let's look at different scenarios. Just remember here, this is from the previous slide. This is what we want. Just keep that in mind. So let's say we have a structure and we put plants in here. Let's talk about CO2. Let's say we're in the winter. We have the vents closed because we want to conserve energy. We don't want to heat up energy. If we never open the vents during the winter, remember that the plants need CO2, carbon dioxide, for photosynthesis to generate the compounds that they need to grow, the sugars that they need to grow. So what happens is that you're going to have CO2 in this closed structure, but as the plants photosynthesize, as the sun gives plants the energy to do photosynthesis, the plants are going to end up using the CO2 in this structure, and the CO2 levels are going to drop. But you're conserving energy, but there's not going to be CO2 for the plants to create the sugars that they need to grow. So that's why we have here that during the winter months, you want to have 1 air exchange per hour. And what that does is that once the CO2 levels are depleting here, remember that outside in the environment, the CO2 levels are 400 parts per million, right? So what you do is that you open up the vents and you slowly let some of that air in to bring in fresh CO2, but it also pushes out that air that has low CO2, right? And it replenishes the air inside CO2. Now, some growers, depending on where they are, the location, sometimes it is cheaper to conserve the heat energy because fuel prices might be too expensive where they are. And they may have a CO2 generator or a CO2 tank next to the greenhouse that will inject CO2 into that structure. And they did the economic analysis, and they found for their specific operation, it was cheaper to put in CO2 than to have the additional cost of heating that greenhouse by letting air in. But there's another reason why you want to have air exchange in the greenhouse, not just because of the CO2, and it's relative humidity. Remember what I mentioned earlier when we talked about water uptake for plants? When the sun heats up the plant, it creates a lot of vapor pressure, right? If you have, during the winter, if you have this structure closed, because you want to conserve heat energy, you don't want to spend fuel heating up the greenhouse, you want to conserve that heat energy. The plants are transpiring. It's like when you go in front of a mirror and you exhale, and you see that there's humidity that accumulates on the surface of that mirror, right? The plants transpire. Like you saw the previous example, that the plants are not exhaling, but are transpiring water molecules, water vapor out into the environment. So what happens when the sun keeps heating up this greenhouse or this structure? The plants are going to start to transpire. And the problem is that this space is going to become saturated with high humidity. And there's many problems that come with high humidity. Well, the first one that may come to your mind is like, oh, we're going to have more diseases, more disease pressure. Yes, that's one thing. But I am from a country that is very humid during the whole year, right? And if it's too humid and you don't have an AC or air conditioner, you can put a fan in front of your face and you're not gonna cool down, right? You're sweating, but you do not feel that you're cooling off, right? And that's because there's too much humidity in the air that prevents the humidity from the surface of the skin from evaporating. And that's what cools you off. The evaporation of that humidity off your skin. That's why sweat cools you off. But in this case, if the air is saturated with a lot of humidity, with a lot of water molecules, there's no more space. What will happen to the water molecules that are trying to leave this plant? They cannot escape. So the plant cannot evacuate that pressure. So that means that water is not going to move through the plants. And that's when you start to have some physiological issues like blossom end rot or tip burn in some leafy greens. And we're going to talk about the reasoning behind it. So that's why you want to have air exchange in the greenhouse. That's why you want to move air, because you want to prevent low CO2, but also you want to prevent high buildup of high humidity. And we talked about that horizontal airflow fans also helps mitigate this, because usually the high humidity air is going to stratify with higher humidity closer to these locations and lower humidity air up here. So that horizontal airflow fans is going to help you homogenize this air, right? During the nighttime, when there's no light, plants are a fascinating organism. So during the nighttime, when there's no sunlight, some plants will go on respiration. And what that does is that the plants are going to use oxygen and generate CO2. So during the nighttime, you also want to have air exchange, right? When the plants are respirating, they're also transpiring, right? There's also some water coming out. So you also want to have some air exchange, but not so much during the nighttime as opposed to the daytime. Okay, so here are the systems inside a high tunnel or a greenhouse that will help you manage air quality. We see here we have the side corners. I mentioned that. Usually you open them to let air pass through the greenhouse and exchange the air. That's very common. Or when you're extending the season, you close this close to sunset to make sure to conserve the energy from the sun and keep the plants warm during the night. And then you open them up during the day, because a greenhouse, even in the winter months, can get too hot, very hot inside. That can affect the plants. Sometimes they're automated based on sensors. You have the exhaust fan here with the louvers. We have the horizontal airflow fan, the HAF fans. One thing that I'm going to show you later, notice that this girl is not using this high tunnel to store stuff. When you put stuff here to store, that's going to prevent proper airflow, right? This one does not have it, but sometimes greenhouses will use a shade cloth that goes inside here. And during the winter months before sunset, they'll deploy these, and this is to prevent the heat energy from escaping the greenhouse up in the air. It keeps the hot energy closer to the plants and trapped, not up here where the plants are not using it. Sometimes they'll have energy curtains during the winter months to increase the insulation on the sidewalls. Sometimes I've seen some greenhouse put like insulation panels here during the winter months on this part of the greenhouse to insulate this structure better. And sometimes they put the insulation panels here on the end walls to insulate this structure and conserve heat energy. Not pictured here, but you also have the heaters, the heating system that you have in your greenhouse, or high tunnel. I've seen some growers that they have 6 millimeters polyethylene bags running through the aisles here, filled with water during the winter months. And what happens is that that black bag is going to collect the sunlight energy and store it in the water. And then at nighttime, that's going to keep the plants warm. Sometimes they'll put a drum here, a black drum filled with water, or they'll put several black drums here filled with water, and that will capture the energy and store it in the water to heat up the locations. And that's why I have here the black water storage containers. And notice here we have roll covers here. So this is a high tunnel that has some active air quality or air temperature management. But sometimes it may get too cold during some nights that they'll put these roll covers on top of the crops, and that will give you extra degrees Fahrenheit of protection. I do not know the specific number, how many more degrees of cold weather you can tolerate inside this greenhouse when you put the roll cover. But those are things that you can use to help you manage air quality during the winter months and during the summer months. Here's an example of shade cloths in an old greenhouse. These are inside the greenhouse. Typically, you're going to see them on top of the greenhouse or high tunnel. Usually, they'll give you 6 to 9 degrees Fahrenheit of protection in the summer, depending on how much shade you want to put. It is recommended that you have between 30 and 50% shade inside. And just think about the greenhouse or the high tunnel covering and the structure, the beams and everything. These are already blocking 20%. So if you want to have 50% radiation or sunlight inside here, if these are already blocking around 20% of the sunlight, you need to get a shade cloth that it is rated at 30% shade. And that's going to give you 50% shade inside here, right? Obviously, you're going to lose some of the total yield. If you're growing tomatoes, you're going to see that the total yield is going to go down, but you're going to notice that the marketable yield or the amount of good tomatoes that you're getting out of it is higher. You're not going to have cracked tomatoes, or you're not going to have tomatoes with poor quality. So you're going to have better looking tomatoes, more of the better looking tomatoes that can make off for that offset in total yields. This is an example of energy curtains during the winter months in a greenhouse. And this is to prevent heat loss through a sidewall that may not be as insulated. Here's that energy curtain / shade cloth that I was talking about that goes on top of the greenhouse. This one is during the summer months, and this is to provide some shade to these leafy greens. There's the exhaust fans here, and on this side, it's not pictured here, there's a cooling pad on the other end of this greenhouse that the exhaust fans pull air through those cooling pads to keep the temperature lower. Also notice here space heaters, and also notice here the HAF fans. Notice that they're pushing air at an angle because you want to have a homogeneous air mixing here. There's another space heater here. Not pictured here, this grower didn't do that, but sometimes they put like insulation panels here. They do not have like the side energy curtains here, but sometimes they put insulation panels here to increase the insulation of the structure to conserve energy. Another thing that I want you to take note is that there's nothing, and I've seen many people, because they're short on storage, there's nothing obstructing the fans. They're not storing things here. They're not parking trucks here. You want to have free airflow here. You don't want to obstruct here. Another example here, there's fabric here. There's like wheat. I don't know if you can see it in this picture, but there's a fabric here that prevents weeds from growing. And I've been to many greenhouses where they do not control weeds around the structure. And then they have like huge hedgerow here of vegetation that prevents proper airflow into the structures. And the other problem with that is that these weeds are hosts for diseases and pathogens. And when it's starting to get cold outside, guess where they're going to go? They're going to go inside the structure because it is warmer in there. And what do you have there? Oh, free food, right? So keep around 10 to 15 feet buffer area with no weeds around your structure for disease pest management, but also for proper airflow to the structure. Earlier, I said about storage. This is a greenhouse grower that I visited. What do you see here? And this is just this part that you can see, like inside this whole wall had things stored in the greenhouse. How do you think it's going to be the airflow to this greenhouse? And the other thing is, this was one of our research projects. There's supposed to be fingerling potatoes in here. And someone forgot to, or maybe didn't want to be there hoeing or controlling weeds in this high tunnel. What's going to be the airflow through this high tunnel? When you have too much vegetation or too many weeds, or you decide to crowd your space because you invested money and you want to extract as much as you wanted from it, this is not adequate. There's not going to be enough airflow. You're going to hurt the plants. And when we're talking about, let's say, tomatoes, which is the number one food crop that's grown in greenhouses because they're profitable, you want to make sure that you have a pruning program. You want to make sure that you prune the excess leaves from the plants, and that helps with air circulation. And when you have good air circulation, you're going to have less disease pressure, and obviously you're going to have better water transport. Now, these are too much pruned. Typically, you want to leave some leaves on top of the oldest tomato cluster, because if you do not have shade cloth, too much sunlight can create unscald damage on these fruits. The other thing is, it makes it easier to work with these tomatoes. Like, it's gonna make it more efficient for your workers to get in there and do the work done inside your structure. And then, like I said earlier, it removes parasitic leaves. Just think about if you left some leaves down here, how much sunlight do you think these leaves are getting? So they're not going to get too much sunlight. So they're not going to have a net positive photosynthesis output. So the plant is going to be like, oh, this is an appendage that I need to keep alive. So I need to dedicate resources to keep those leaves alive, even though they're not productive from a photosynthesis perspective. So if you remove these leaves, they're not parasitic anymore, so the plant can dedicate those resources to grow the tomatoes. And excess pruning can lead to higher sunscald or damage on the tomatoes. And this is just a general rule of thumbs for pruning tomatoes or vine crops. First, you want to remove any suckers, take those out, and then remove any lower leaves that are no longer needed for production. Typically, they're all the leaves under the first cluster of tomatoes, which you can see here. This is the first cluster that was developed by this tomato plant, or the oldest, or the ripest one. Anything underneath these one can go out. All right, so why did I spend so much time talking about this? Because you have some issues related to water transport. When you do not have proper air movement, and you end up with microclimates that have high humidity. Blossom end rot is one of them. Tip burn is another one of them. And obviously you have disease pressure. And typically we see this more often or with higher frequency coming out of winter, spring, and then coming out of summer, going into the farm and winter months. That's because people want to conserve energy. So these are caused by environmental conditions. These are not diseases. These are caused by the environment. And any conditions that affects the absorption of calcium will end up in these disorders. That means that the plants are not able to put enough calcium on the tissue, so the tissue sinks and it dies because there was not enough calcium to keep those cells alive. And even when the calcium levels are high in the soil, right? So how so? Like, and then I've seen many growers like say like, oh, just add more calcium into the irrigation system or into your fertility program. No, that's not the answer. Think about, how do you take pills? And you're taking a big pill, and I tell you you have to take that pill without water. What are you gonna do? Huh? So calcium enters the plants to the roots with water, kind of like how we take pills with water. It helps the pill get through inside our body. The same with calcium. Calcium moves with the water. So if you have high relative humidity that prevents transpiration, water is not going to move. Therefore, calcium is not going to move through the plant. How do you prevent it? If you're growing indoors, make sure that you have all those structures or all those systems like the horizontal airflow fans, and that you have a proper air exchange ratio to avoid humid, stagnant air. This is what I was mentioning earlier. You want to have one air exchange per hour, even though it may lead to a little bit more costs in terms of heating that greenhouses. Be consistent with your watering. Just remember to keep the soil moist but not saturated. Especially if you're growing in the soil, look at sensors to monitor the humidity of the soil and look into an automated system. Please let me know if you have any questions. These are things that are preventable, and just think about the air quality and how they can affect the plants, especially during the spring, fall months of the year.